Here we are with 17, Koyaanisqatsi. The goal is to create balanced chemical equations. So, if you haven't done 16 yet, you should do that first. That gives you a step-by-step way to do this. However, there's some guidelines here. Draw ionic pictures with proper charges to figure out the number of positive and negative ions, reactants, and products. So here's example number 1. We have 4 salts. They're underlined. Sodium carbonate, zinc chloride, sodium chloride, zinc carbonate. The pictures for sodium carbonate and zinc chloride are already shown. We need to draw pictures for the products. Sodium chloride, zinc carbonate. What are their pictures? Sodium chloride. Sodium is Na, and sodium has a +1 ionic charge. Chloride is Cl with a minus. So this is easy. Sodium chloride looks like that. 1 + 1 -. How about zinc carbonate? You'll have to look at the back of your periodic table for this. When you do so, zinc is a +2 ion. Carbonate is called polyatomic. Many atoms, 1 charge. Carbonate is CO3. The charge is -2. So there are the pictures for sodium chloride and zinc carbonate. We've done step A, I should say. Now, step 2 or step B is to write the correct formulas for the salts. First one has been done for you. That is, in fact, Na2, 2 sodiums, 1 carbonate. The second one, I see 1 zinc. I see 2 chlorines or 2 chlorides, CnCl2. This one I see NaCl. Notice I'm leaving some room in the front and some room in the back for other symbols. And this last one, zinc carbonate, ZnCO3. No charges are shown in the formulas. No charges are shown in the balanced equation. B is done. Now C is the new concept here. Balanced equation with coefficients. So when you look at this, I'm hoping you see 1, 2 sodium ions in the beginning, but only 1 sodium ion in the end. We need a second one. So it'll go right here. But for every plus, there's a minus. So this will be need to be another sodium chloride. You can't just have another sodium. It must come as a compound. You should see that's good because there are 1, 2 chloride ions in the beginning, and now there are 1, 2 chlorides in the end, 1, 2 sodiums in the end. This is all good. The way you write that in the equation is with a coefficient. It's a big number 2 in front. It's a multiplier. 2 sodium chlorides. I'm hoping you see them right there. 2 copies of sodium chloride. The zinc is fine. There's just 1 zinc in the beginning. There it is. There's 1 zinc in the end. There it is. And there's 1 carbonate in the beginning. There it is. And there's 1 carbonate in the end. There it is. This is now a balanced equation. C is done. Last one is to label each salt as solid or aqueous. There's only one of these salts that is insoluble. Only one of these salts will be marked as a solid. You should find that out by looking at your solubility chart. So pause this video, find it out, come back and see the answer. Zinc chloride is soluble, therefore Aq is the proper label. It will be dissolved in water. Sodium chloride is soluble. The ocean is filled with sodium chloride. Zinc carbonate is the insoluble. That's the one that gets labeled solid. This is now done. Balanced equation with all the proper symbols.